Hello and welcome to the first episode of Innovation Celebration, a new podcast in which we will discuss recent achievements in the fields of science and technology, celebrate the people behind them, and describe how these achievements benefit human flourishing in the long run.
My name is Angel Werth.
I'm Thomas Walker.
And we both work for Objective Standard Institute. We're both fellows at OSI, which aims to promote self-development and philosophy. In this show, we're going to be focusing on we're going to really be digging into 2 to 3 developments in science and technology per episode. And then at the end, we're going to have some honorable mentions because there are so many cool things going on. We really can't talk about all of them in detail, but it's worth mentioning some of them.
Yeah, definitely. And we just want to caveat that by saying that, we will celebrate the people who were involved in these achievements, but that's not necessarily an endorsement of them or the organizations involved. Everyone pretty much who we're going to be talking about probably has some undesirable activities or something that we may not want to endorse. So, not a mention or a celebration is not necessarily an endorsement of everything somebody does.
Absolutely. And just to briefly touch on what the value of this podcast is, firstly, it's an act of justice to celebrate people's achievements that help further human progress. Secondly, it's really, really helpful, I find, to study how success happens. How do people make significant achievements so that we can then reproduce success in our own lives? And finally, it's nice just to hear some good news sometimes.
Yeah, and it's also, we want to try and encourage more of a kind of positive attitude towards science and technology, encourage people to take an interest in those fields and try to see them for the positive life-enhancing values they are.
Mm-hmm. Most definitely. So I think Tom is going to start us off with our first major topic of the day.
Yeah, so this is the news just yesterday on the day we're recording on June 7th. That Jeff Bezos has announced that he intends to fly himself on the first flight of New Shepard, which is the new space launch system that his company Blue Origin has developed. He invited his brother to join him on that maiden flight. So it's just very exciting to anyone who's big on space exploration the way I am. Blue Origin was founded. Well, Jeff Bezos founded Blue Origin back in 2000, so actually before Elon Musk founded SpaceX, and he's piled tons of his money, billions of his own money from sales of Amazon stock into developing this project. It's a fantastic example of someone who has not only done wonderful things in creating Amazon and been quite justly rewarded for that in the wealth he's earned by just making so much convenience for all of us. Anyone who has Amazon Prime, just having deliveries the next day of anything you could possibly want. It's so easy to get hold. We're trying to find you a dress in the right size that's so hard to find in a shop. You can just find it straight away. The convenience he's brought and the jobs he's created, and just so much that Amazon's done now in developing robotics and things like that is incredibly exciting. And then he's not giving that wealth away. He's reinvesting it into something he cares about that's really going to make a transformative difference to the future of the human race. So I want to talk for a minute about New Shepard as a launch system and how it's different to other space launch systems that are on the field at the moment. Because traditionally rockets are, those that have been developed by NASA and other space agencies in the past tend to be disposable rockets. So as they launch, they burn through the fuel in the first stage, that falls away and falls into the sea. Second stage falls away and burns up in the atmosphere. And only the bit on the top does anything useful, goes off into space or, does a mission and comes back. But even then, you don't generally recover that last. Or the space shuttle, was partially reusable, but had to be rebuilt top to bottom every time before it flew again. New Shepard and the other spacecraft that Blue Origin is developing, New Glenn, they're both named after astronauts from the Mercury 7 program, the first Americans to fly in space. They're both intended to be fully reusable. The entire vehicle comes back and goes again, the same as SpaceX's Falcon rocket is. But New Shepard is a suborbital rocket, so it doesn't go into orbit. It just goes above the Kármán line, the official designation of space, which is 100 kilometers, 62 miles above the Earth. for a short time, which is enough time for some tourism to go on, everyone to look out the window and gawk at how amazing space is, or to do some science, and then drops back. So that's a much cheaper way of reaching space than a full orbital launches. So that makes space tourism available far more cheaply than trying to launch somebody on an orbital rocket, whereas New Glenn is intended as an orbital launch system.
So both of these systems are being developed by Bezos and his Blue Origin company.
Yes, so there's sort of three big players in the private spaceflight field at the moment, and they're all entrepreneurs from other fields. It's Elon Musk, who obviously made his money through PayPal and Tesla. Well, not PayPal, he made his money through, and then he's used it to do Tesla and SpaceX. And he's doing, but SpaceX is entirely focused on orbital launches. So the Falcon is a surface to orbit system designed to launch freight initially and then passengers more recently, through a lot of funding from NASA to develop. So he developed a freight launch system commercially, and then NASA gave him $3 billion to turn that into a human-rated launch system to fly astronauts to and from the International Space Station. So that's very much SpaceX's field. And we'll talk about the government funding dimension of this in a minute. On the other end of the scale, Richard Branson and Virgin Galactic is purely suborbital. So he's just creating a system for tourists to, just go into space for a few minutes effectively and then fall back, which, you don't need a heat shield. You don't need all this extra. The Virgin system launches from a plane, and that had its first successful space flight a couple of weeks ago, which is very exciting as well. New Origin is doing both of these. So, it's sort of a 2-for-1 really. And I do want to talk a bit about Bezos's reasons for doing that, because I think it's very interesting. His passion for spaceflight and the reason he wants to develop it as a technology is a bit different from Musk. There's some overlap, but it's a bit different as well. So I'll go on to that in a minute, unless there's anything else you want me to ask about that first.
Well, so you mentioned that there was something, or maybe you didn't mention. Oh, yeah, but is it not the case that with one of the things that makes this new program from Blue Origin unique is that the whole vehicle comes back to the pad, right?
Yeah, so, it's not quite that simple, but there's a booster stage on New Shepard, which detaches and lands itself again, and then there's a capsule that lands separately.
Right.
So it's a kind of 2-stage launch system, but it's not like the Falcon where you've got boosters separating and then a stage coming off and then another stage coming off.
Sure.
Because it's and also it lands vertically, whereas other systems, there's Dream Chaser and the Dragon capsule, which have to parachute back and land in the ocean or land on a runway. So this is vertical takeoff, vertical landing.
And what's the advantage of that?
That's quite a good question, really. They all have different advantages, really. I mean, so landing vertically on the ground means you can land basically in the exact same place you took off from.
Oh, sure.
Dragon, the SpaceX system, is designed so it can land on either land or sea, but you have to have a wide open flat area in case it doesn't land where it's intended to. Dream Chaser and the Space Shuttle Evolved could land on airport runways, which gave them a lot of flexibility about where they could come in. But it's difficult to aim a spacecraft from orbit or from extremely high altitudes to land in a specific location.
I would imagine.
You can go off route quite easily. The Russians landed one of their Soyuzes in a lake once by accident. So it's easy for that to go wrong.
Sure.
But no, so Bezos has talked a lot about his reasons. And I say he started this before Elon Musk did. So even though Elon Musk has kind of got to the finish line first, again, with a lot of help from the American taxpayer, Bezos has not benefited from that to anything like the same degree. That I will say briefly that New Blue Origin got a small amount of funding from the NASA Commercial Crew Program, same program that SpaceX went through with the Dragon, but they only made it through the first phase and they didn't go any further with it. So he got 25 million in total development costs, whereas I say SpaceX got over 3 billion from NASA for that. It's just wildly different amounts of public funding involved there. All of the development really of New Shepard has come out of Bezos' own pocket. He sells $1 billion of Amazon shares every year to finance this. So this is just essentially purely ever since that one bit of NASA dealership, which he very quickly got out of because they've had falling outs with NASA about access to launch sites, and they felt NASA were favoritizing, which is really, if you get government money involved in private development like this, you do get favoritizing going on. that's exactly what he saw. They were, getting into bed with SpaceX and giving them preferential treatment. So he pulled out of that. And so the New Shepard, the system that's launching next month with Bezos on board, is he paid for the thing himself, and now he's going to get what he really deserves, which is his chance to fly himself and his brother into space, which is what he's wanted all his life.
Right.
But he's talked a bit about why he wants to spread humanity to the stars, and part of it, I think, is just what I can totally understand is that desire to see space, to live in a society that can do that.
Mm-hmm.
But he sees it as a solution to the depletion of resources on Earth. And so a lot of people, environmentalists and the like, will talk about us depleting the planet, and they'll try and restrict human activity, or say we should reduce the population, all sorts of very anti-human ways of addressing that. But what Bezos seems to be coming from the quotes I read from him, is that he wants humans to have access to resources to live. And he's conscious of us, running out of things that we need for our survival, and he wants to expand humanity into the solar system so that we can continue to grow, continue to improve our lives. So he has a quite good, I think, philosophic reason behind this, which is wanting to improve human flourishing, not impede it. So I think, that's, people say there's no planet B, and there is, if you go to it and colonize
find it.
Yeah, and there's a lot of development that needs to go into that, and all of these guys are putting a lot of development into how we might live on the moon and Mars in the longer run. But it's very clear, reading and listening to him talk about this, that he has a vision for a thriving human civilization that spans the solar system. I think that's a beautiful vision, and it's just amazing to see someone, as I say, this wouldn't be possible if he hadn't earned the wealth he has.
Certainly, yeah.
So, people who complain about him being too rich, and he is incredibly wealthy, he's the wealthiest man in human history, but I think if we look back in 50 or 100 years, our species our civilization will be so much wealthier as a result of that work, and his success in becoming that wealthy is
and in how he's invested it.
His money isn't just sitting in a bank account somewhere. It's going to work, changing the world for the better, according to his idea of how the world should change to the better, not somebody else's. If the government takes your money and spends it on something, you don't get any say in how that changes things.
Yeah.
Whereas he's developing something that's going to really create the world he wants to see created, and it's just wonderful to see it. And I absolute kudos to him for flying on the flight himself.
Yeah.
The first manned flight. This New Shepard has done a number of unmanned launches into space now, so it's it's a tried and tested vehicle, but this is the first time it will have carried crew on board, and he's going to be right there on board, and that that's every kid's dream who ever took an interest in this stuff.
Mm-hmm.
So it's just incredible to see.
Absolutely. All right. Is that all you wanted to say on that?
I think so, unless you had any other questions you wanted to bring up.
No, I don't think so.
I was going to briefly talk, I suppose, if we're talking about the government funding aspect of it, the other spacecraft that Blue Origin's developing, New Glenn, that has benefited from some funding from the Air Force. So that's quite a different situation to the NASA funding that SpaceX got, because New Glenn has a military application. It can, it will launch satellites for surveillance and, actually national security purposes. So that's received $500 million from the US Air Force. But as I say, I think on a philosophic level, that's really a different situation, because there's a legitimate role of government involved there in national defense, and so that's going to have that function. But that's completely separate from the tourism function of New Shepard.
They're different projects.
They're different ships. Now, obviously, military technologies have civilian applications, and New Glenn will have all sorts. Will have tourism applications as well. Mm. But at the moment, an orbital flight as a tourist is going to set you back $10 million at least. Whereas New Shepard will offer $200,000, still beyond most of our reach, but a hell of a lot more people can benefit from that. And the more that's developed, the more people pay for it and take up on it, the more those costs will go down.
Yeah.
And we're probably a decade or two away from a moderately well-off person being able to do this at some point in their lives. which is, again, just an incredible gift to be given by a capitalist, really.
Lovely.
So, no, I think I've covered everything. So we're probably going to move on to your one if you've not got any more questions.
No, I think that covers it. So we're going to switch gears now and talk more about developments in biology, which is a field I have a little bit more experience and knowledge in. So specifically, the development I wanted to dig into this week is about a fungus that scientists have developed, bred really, to protect honeybees. So for context, honeybees, well, they face a number of threats, really, but the one that this one is addressing is a mite called Varroa destructor. It's very aptly named. And so the varroas are external parasites that they themselves cause a disease called varrosis, which they cause by attaching themselves to the bee and sucking out all the fats. They also can vector at least 5 different viruses. And what that means is when an insect attaches or inserts its mouth parts into an animal or another insect, they can sometimes be carrying a virus that they picked up from one of their previous hosts. And so they can transfer the virus from one person or animal or insect to another. This is the problem that we have a lot of the time with mosquitoes carrying things like West Nile virus. You know, they pick it up from one person, they go and bite another person, and then they move the virus. You can have the same thing on a smaller scale with mites and honeybees.
Can I pause you there? So this all sounds like nature doing its gruesome thing that it always does. You know, one thing eats another. Why should we care if a mite eats a bee or infects a bee? You know, how does this affect us as human beings?
Yeah, so honeybees are super, super important to agricultural production, particularly outdoor agricultural production, because they make honey, but they also pollinate field crops. And there are a number of crops, particularly in the Cucurbitaceae family, which is your squashes, your melons, your cucumbers. Those sorts of plants tend not to develop properly if they're not pollinated. And honeybees are one of the major pollinators, to the extent that many farmers will keep or rent honeybees specifically for that purpose. So it's directly related to food production.
I think if I may throw in a philosophical aside there,
Okay.
Obviously the agricultural function is incredibly important, but I worry that sometimes we actually understate the importance of sweet foods as a thing to make human beings happy.
Yeah.
So I think the honey production should, because when we talk about controls on sugars and things like that, it's actually a really important benefit to humankind to have pleasant experiences like eating sweet foods. So
yes.
I think the honey alone is a worthwhile enough reason.
Yeah.
The rest is just even more.
Well, not only do people eat honey, they use it in cosmetics and things like that too.
Yeah.
So honey is incredibly useful. So we then clearly have reason to be concerned about these varroa mites, that if you've got a significant mite infestation, that can wipe out a whole hive. So these are not just killing the lone bee here and there. These are significant problems, and they've been a problem for decades. And so what's happened is something that happens a lot with problems in agriculture, is that you develop a chemical that would kill the problem, in this case, the mite, and then the mites develop a resistance to your solution, and so it doesn't work as well. So, as I said, this has been a problem for a few decades now. So starting 20 years ago or so, the United States Department of Agriculture started doing some work on this, and they found a fungus called Mite-Killing that does kill the mites. And they do that by landing on the exoskeleton of the mite. So if you remember, insects have that hard exoskeleton to protect them. But these spores, when they germinate, can go right through that. And then grow inside of the mite until it is dead. And it's kind of gross looking, but kind of cool. We've got a quick time lapse that we're going to put in the description if you want to see how that works. It's like 22 seconds long. So this fungus looks like a classic example of a biological control, which is when you use a small insect such as a mite or a parasitic wasp to kill a problem insect or pathogen. The only issue with this solution in this particular case is that fungus, the Mite-Killing, doesn't grow well in high temperatures. And in beehives, it can get up to 35 degrees Celsius or 95 degrees Fahrenheit. That's too high for the fungi. So a lady named Jennifer Hann, who's an entomologist at Washington State University, led a team who set out to fix this problem. And so they used a related fungus called Mite-Killing bruneum, which has been used as what's called a fungal entomopathogen. It's a big word that just means a pathogen for a bug. So the fungi kill the pathogens. And it's been, this particular fungus, the Mite-Killing bruneum, has been used against Asian longhorned beetles and on insects that feed on the roots of plants. So it's been used as a biological control agent in the past. So Hann and her team decided to start by getting this fungus to function the way that they needed it to against the mites in high temperatures. So they started out by stressing the fungus, by starving it, adding hydrogen peroxide to the plates, things like that, which increases the rate of mutations in the fungi. They took some of the spores from these stressed out fungi and put them in an incubator, which
stressed out fungi.
Yes,
sorry.
They're stressed out. So the stressed out fungi go in an incubator, which is, some of you may know of incubators for things like chicken eggs or whatever, which is basically just a really warm device that you put things in to grow them. So they put the spores into the incubator and slowly raised the temperature. Most of the spores died. They used the ones that survived to then breed the next generation. And so after about 7 rounds of this, they had increased the survival rate from 44% to 70% at that key temperature we were talking about before, the 35 degrees Celsius.
So, I mean, this is selective breeding, isn't it? Yes. So this is, yeah, if anyone's seen that wonderful video on YouTube of Ray Comfort, the Christian young earth creationist, talking about the banana and how perfectly evolved for human consumption the banana is with its skin that peels off, and humans have bred it to do that specifically by selecting the best ones and breeding those, and how we created such a diversity of dogs and cats and we use for different functions. Yeah,
humans have been selectively breeding for centuries, and that's how we ended up with most of the crops we have today. If you want a fun exercise on that, look up wild tomatoes or wild corn. They look nothing like what we think of as tomatoes and corn, because we've bred them over so many years to be exactly what we need them to be.
So and likewise with the wild banana is this sticky green thing with seeds in it that you wouldn't want to eat. You can't get the skin off of it. And people who object to genetic modification and GM foods and all this kind of stuff don't realize properly that the vast majority of what humans eat is already bred into a certain form that's completely unnatural and would not be anywhere near as good for us if it was.
Wouldn't be as nutritious, they wouldn't be as big, they wouldn't taste as nice. This sort of breeding has gone on for a long time. It is a bit more complicated though when you've got fungi, because there are many types of fungi with many complicated life cycles, and so it can be tricky. So Hann then enlisted her colleague Nicholas Nager, I hope I'm saying his name right, to increase the deadliness of the fungi, because sometimes when you culture something in a lab like that, you can reduce the virulence. So they first tested their fungi that's now able to handle the high temperatures. They first tested it in a hive. And then once some of the mites had died, they tested the mites, and only 4% of the dead mites had the fungi on them. So they used the spores from that 4% and then did a few more rounds of that selective breeding we're talking about, and they got the kill rate up to 60%. So it's quite good. And then they wanted to say, okay, now we've got this more deadly form of this fungus that can handle the high heat. How does that compare to some of the treatments that we're already using? So oxalic acid is a treatment that's commonly used by small-scale beekeepers, such as, a farmer who's got a couple of hives might use this to keep out the mites. And using a small dose of the fungi, it was just as effective as the oxalic acid, but without the risk, because oxalic acid and other miticides can sicken the bees themselves and not just the mites and kill them. And if it doesn't sicken them, it can cause reproductive issues. So that was just a small dose of the fungi. They haven't tested it yet with a larger dose. With a larger dose, it might be more effective still. So it is a little bit more expensive to use biological control agents. They're a little bit tricky to keep alive, and more broadly, just it takes more skill and more money, but you then don't have the risk of the mites becoming resistant to the pesticides. You don't have the risks to the bees. So there's a pretty significant trade-off there.
So there's only one other thing I wanted to raise quickly, which is just about the funding, because it sounds like a lot of this has gone on through state universities and state departments.
Yeah.
But the commercial benefits are obvious. So one would hope that, in the absence of state involvement in these fields, there would still be a commercial motivation.
Well, it really depends. So this was done at Washington State University, which I think is a public university. And public universities vary in how much state funding they get. In a lot of these, it's called cooperative education departments that work with, or cooperative extension, pardon me. There are a lot of programs, particularly in agriculture, that work directly with farmers and producers. And so a lot of times they're able to get their funding from the industries that they're working with, or at least some of it. So it's usually a collaboration in that sense, but I didn't look into this particular case. I just know from my experience of working at Clemson University, which started the extension program, essentially. I worked with the extension program there. And so we got funding from the pest control industry to provide them with better training and research for the pest control industry. So because they have direct applications, a lot of times those in the industry are willing to help pay for the research.
Yeah, and that's what you want is, science being advanced by the people who will benefit from it, really. Regardless of how it's funded in the long run, there's any question that people like Hannah and Nager, pursuing this presumably out of a passion for science that got them into this field in the first place.
Yeah, they're both entomologists. They're probably
doing incredible work.
Yes, interested in bees and mites, which is fantastic. So, given that, I think we're ready to move on to our honorable mentions, which we have 4 of today.
Sure. Yeah. So I say we'll do a little shorter preamble about some other interesting developments that have gone on, and it seems to have worked out this time that you're doing all biology and I'm doing all aerospace. So those are our fields of interest, really.
Yes, and in my case, my field of education as well.
Yeah, and I'm very interested in architecture, building, engineering, that kind of stuff as well. So it won't be as basic as this area. It just so happens that with what's in the news currently, I've ended up with all aerospace. You ended up with all medicine and biology. But I'm another aerospace thing to jump on with, which is that United Airlines has placed an order for 15 supersonic aircraft from Boom Supersonic. And if you go on the Objective Standards, there's a brilliant article we'll link below in which our colleague John Hersey interviews Blake Scholl, the founder and CEO of Boom Supersonic, about his journey of trying to develop supersonic air travel, which is yet another example of a venture or a capitalist entrepreneur trying to change the world into the world they want to live in. I would love to live in a world with commercial supersonic flights where we can, as you may tell, we are from opposite sides of the Atlantic, and where we can see our families and things much faster and just bring the world closer together. And Blake Scholl is very much doing that, and United's investment in that project is a real catalyst to drive it forwards, because he's got the XB1 at the moment, which is a single seat prototype of the technology, but the Overture will be a full size airliner, and this will halve journey times across the Atlantic. New York to London in 3.5 hours. Is transformative. It's also worth noting, and Boom make a big deal of this in their publications, that the Overture will be completely run on sustainable fuels. And I'm not highlighting this necessarily as an environmental advantage, more that it will help assuage those who attack the aviation industry on environmental grounds. So I'm hoping that the fact he's developed an aircraft that isn't just fast and efficient, but is also fuel efficient and unpolluting, will equip aviation to survive in an environment that is currently very hostile to it.
Well, and it also speaks to consumer demands, because there are a number of consumers who are concerned about sustainability. So, whether they're concerned about that on philosophic grounds or not, there's something to be said for responding to consumer demand in that way.
Exactly, yes. And I have an article on this myself, which I might link below as well. But aviation is so important to human flourishing, to human well-being. Going backwards on that, like France and other countries are doing now, and trying to restrict air travel is antithetical to human well-being. It brings us close together. It enables trade. It enables people to see the world, and it overcomes national boundaries. And last year, coronavirus and the restrictions that followed it really put up walls between different countries and societies. Aviation has the opposite effect. Mm-hmm. So anything that we can, somebody like Blake Scholl can do that helps aviation survive and remain free and remain competitive and improve and continue to do what it does so well and connect us together, I think is a wonderful thing. So the fact he's made it a sustainable fuel aircraft as well, I think will be really good in the long run for keeping aviation thriving as an industry.
Most definitely. So our next honorable mention goes to Jason Chin and his colleagues at the Medical Research Council Laboratory of Molecular Biology. The folks over there have had a big breakthrough, or made a breakthrough rather, in developing medicines from bacteria. So how does that work? Really briefly. Bacteria, because they reproduce so quickly and because they're so easy to edit, relatively easy, you can edit their genes to get them to produce different amino acids. Those amino acids are then used to produce a number of things, but most notably for human flourishing, medicine. Life-saving medicines can be produced from these bacteria. And what Chin and his colleagues have done is figured out how to make more amino acids at a time, which will make the process of developing new medicines cheaper and faster, and really directly save lives. So that's really fantastic.
Anything that saves lives is good by me, generally.
Yes.
Back into the space field, but in more of a scientific way this time, rather than transport so much. Scientists have been using a new technique called astroseismology to learn more about the early formation of the Milky Way galaxy. So very, very, very quick explanation. We live on Earth. Earth goes around the sun. That's the solar system, the sun and the planets. And then that goes around the center of the Milky Way galaxy, which is one of many billions of galaxies. But this recent piece of research has used this new technique to study the hearts of distant stars at the center of the Milky Way galaxy. And that's determined that it's given much more precise definitions of the ages of these stars, but has also learned a lot about their internal structures and determined that a number of them don't actually originate from the Milky Way, but rather from another galaxy that collided with the Milky Way 10 to 11 billion years ago. Mm-hmm. So it's just another wonderful example of how astronomy and science is telling us the truth about our history as a universe, as a civilized, as a species. It's replacing a fictionalized account of how the world came to be with the real story, and the real story is so much more interesting, so much more incredible to learn about. And the more we learn about that, the more awestruck I am by it. So
the wonder of the stars.
Imagine galaxies colliding, and knowing that our home formed in such a spectacular way is quite incredible.
Most definitely. And finally, researchers at the University of Alberta in Canada, led by Dr. Pierre Boulanger, I hope.
Boulanger, I would read that.
Probably. His French is better than mine. But they have developed an artificial intelligence tool called Project DR. And what this tool does is it projects medical images, so things like MRIs and CT scans, directly onto the patient's body. So the doctors can see exactly what's going on inside the patient by looking at the patient.
That's incredible.
It really is very, very cool to see what's going on at the same time. And the researchers expect that this technology will help with medical education. I mean, imagine being able to teach medical students what's going on in a patient's body by showing them. That's such a powerful teaching tool. Research, seeing how different things would affect them, physiotherapy, and surgical planning, being able to plan out exactly what needs to be done before any cutting is occurring. So a lot of cool applications for that. Again, directly life-saving technology is really exciting.
Yeah, that will prevent a lot of accidents and missteps in operations as well. Being able to get in and see things as they're happening is pretty incredible.
Yes.
So in order to sum up, today we talked about Jeff Bezos' announcement that he will fly on the first flight of New Shepard. A small addendum to that, by the way, we realized after shooting that section that Bezos Blue Origin has spent quite a large sum of money unfortunately lobbying Congress to try and get the contract for the NASA moon landing project, which NASA awarded to SpaceX, and Blue Origin has been lobbying to get a share of that. So that's an unfortunate piece of sort of cronyism on the part of Bezos, but it doesn't have a bearing on what we're discussing here, which is New Shepard and the development of New Glenn as well. This, what I said earlier about Bezos's use of government finance is still true as far as that's concerned. It's just unfortunate they seem to now be slipping into more favor-seeking territory with this moon project, but we'll see where that goes.
Right. The projects we talked about were funded, as Tom had said, but this is a separate project from the same company.
Yeah.
But following that, we talked about the development of a fungus that will help destroy mites that are threatening bees.
And then we talked about briefly United Airlines purchasing Boom's new supersonic aircraft.
And the gene editing that's been done to make it possible to get more proteins from bacteria, which are used in making medicine.
And then the new use of astroseismology to determine the ages and origins of early stars in the Milky Way galaxy.
And finally, we talked just briefly about the medical imaging project, Project DR, which allows doctors to see medical images projected onto the patient's body. So that's all been very exciting. And thank you guys so much for joining us on Innovation Celebration.
Innovation Celebration, in which we celebrate recent innovations in science and technology and how they influence and improve human flourishing. Please join us hopefully next week for another selection of recent developments.